everybody, welcome back to this tutorial in TouchDesigner on how to orient instances to an object. Today we're looking in how to do this in 2D format eventually, and hopefully we'll look at it in 3D. So let's get started. Today might be actually pretty simple. It's not as crazy complex as you can imagine. And it's pretty straightforward. So there's obviously tons of way to do this. You can do this directly in Chop World with the object chop. Obviously, using chops in instancing paradigm is not my favorite approach. So let's look on how I do it. So as we usually do in those tutorials, let's grab a base. Let's rename it orient to object. Superb. And let's do as we've done previously. Let's customize the component. P for parameters. And let's add a page that we will call settings. Add the page. It appears here. Let's click on it. And I want a resolution. I'm gonna grab the XY component right here. So I have it here, res X, res Y. And I like always to have my aspect ratio close and handy. So it's gonna be a float. Let's add this. Okay, we have everything we need to start. Let's put in a normal resolution for this kind of setup. Eventually we can pump it up. We'll see how to do this a bit later. So I'll take a 16:9, and my aspect ratio is going to be my resolution X divided by my resolution Y, as I always do. Okay, we can toggle this read-only as it will never have to change again. So let's jump in the network. Let's grab a GLSL top. Beautiful. Let's let's rename it GLSL UV, because from this GLSL we'll be writing another one very shortly. We will just be exporting or outputting the position and also the B scale, sure. Okay, so as a vector, now before even we go to vectors, let's go to the common. Let's put in our resolution. Let's bind it, because if I change it here, I want it to change it up a level too. Okay, in the vectors, I want to add, let's put a URes. And last time we just grabbed those parameters and slide it here. I just want to show you another way we can do this. Me.width or me.height. Superb. And uAspect. And this time we will bring it from here. Is that correct? Yes. Okay. Very nice. Let's open this in our code editor that we prefer. And let me just disable Copilot for GLSL while we will be doing this. Okay. So first let's import our uniforms. So uniforms are variables that are outside the scope of our GLSL code, so that's a way to bring in variables. So uniform, we're going to bring in a vec2, and we're going to bring in URes. Oh. And then another uniform, which is going to be a float, and we're going to call it, obviously, uAspect. Okay, we can delete this. We're gonna keep this variable to output all the data we want to export. Yeah, export, output, sure. So let's create a vec2 variable that we'll call UV, and we're gonna grab the vuv.st. that is given by TouchDesigner. We're gonna scale so we've seen this a couple times already. We're gonna scale our UV with our aspect ratio, so it's aspect correct. So just before we do this, let's see it first. So let's bring in the UV here. Okay, so let's go in here, let's put this in nearest pixel, and 32 bits. So if I make my viewer active and I click on V to see my points, we see that all my points are normalized between 0 and 1, and I want my points on my x-axis to be not normalized but scaled from 0 to the aspect ratio. So to do this, I'll just take my x component of my UV, so uv.x, and I'm going to multiply it by my u aspect. And right when I hit save, you see that everything is now proportionally scaled and now more uniformly distributed. There's equal spacing between each points now. Okay, great. Next, I want to export in this color buffer the size of my instances. So let's bring in a p scale. And let's call this guy, a new variable that we'll call p-scale for particle scales. And we're going to make it 1 divided by our u res.y. Okay. Why are we taking the y-axis? Is because the y-axis is always going to be between 0 and 1 in this setup. And the x-axis will scale with the aspect ratio. So if we take the y, will always be between 0 and 1, and it should always work. So let's now put this variable inside our output buffer. So let's put the p-scale here, and that's all we need to do for this piece of code. Okay, V to go back in texture mode, and let's put this full screen again. Okay, let's add a null, and let's name it position, because position are going to be stored in here, and also we also know that the p-scale is in there. Okay, let's create an arrow, because we want arrows to orient to the target. So to grab the arrow, to create the arrow, let's take a rectangle. Okay, let's give it maybe a little more like this is the first part of the arrow, and I want to have little round corners, not too much, just a smudge like this up. Okay, this looks fine to me. Let's bring in a circle. Let's have 3 divisions because I actually want a triangle. Let's add in a merge. Merge those 2 guys. So this triangle is way too big. So let's bring down the radius and let's offset it a bit smaller, this radius, please. Yep, I'm happy with this. I don't want it to be more complex than that. Okay, and let's take all this and let's put it in Geo. So we can just connect it in that way. And let's recall right away our Geo arrow. Okay, in our nulls here, I'm just gonna put this in nearest pixels. Okay, let's go in instancing, click it on, bring null position as the default instancing up, and we're gonna stay in the XY plane. So let's just grab the R and the G values. So this is looking quite good. You don't see it, it doesn't look perfect yet, because in our scale attribute, let's bring in the B, which was our P scale, if you remember correctly. Okay, that's super, but it's still a little big. So let's just grab a transform and let's make it a bit smaller. Yep, just like this. It looks good to me. Okay, so we have our instances, and now we want to orient them to a target. So first, let's see how we're gonna just create the target. So target is gonna be quite simple. Our targets for this one is just gonna be a simple circle. Okay, and let's keep it like this. Let's add a transform, and let's call this one a transform target. So like this, we're maintaining procedural thinking where we're not moving, like our source is not being touched. We're moving it in the second operation, which is the transform sub. And this is gonna go straight up in geo, and we're gonna call this one target. Let's just render this really quickly, just so we have something to watch. Okay, let's have a camera. Okay, and let's bring in mats. So this guy here and this guy here, and let me rename all of these. So constant arrow and constant constant target. Let's drag it on here. Okay, so this is obviously way too big. You can see it here. Let's make it quite smaller. So I'm actually right now, I am in my circle stop, kind of breaking my rules of not touching it, but I don't mind. Okay, let's put this right away for now at 0.5, just so it's at a more reasonable place. Now let's place our camera. So we've seen that the other time. Wait, let me add a null and call this BG, and let's put the display flag on, and I'm gonna zoom in it just to make it a bit smaller so it's not that much in my face. And the camera, because we're gonna stay in 2D for this one, let's be in orthographic. And the very neat trick of using the aspect ratio for our ortho width and putting ortho origin at bottom left. And look at this, this is now perfectly, the camera is perfectly placed. Okay, let's before we write more code to orient our arrows, let's look at it in some pseudocode. Okay, so I've prepared a little visualization so we can see this in a pseudocode. So let's think about it. Think about this. So we've got a position which represent each one of our arrows. Okay, then we've got a target, which is going to be our circle sap. We want to orient each one of our arrows to the target. So for this, we need to do something which is actually pretty simple. We want to create a vector which is going to be target minus position, just to have a vector which is going to point from P1 to target. Once we have this this vector, we want to do a tan, which which is Vy divided by Vx, but in GLSL we'll just have to put in Vy and Vx as parameters. And once we have this angle, we're just gonna convert it in degrees, because a tan is gonna output us a radian. Okay, so all this is pretty standard in some very simple trigonometry. Okay, so let's go ahead and implement this. Okay, so back in our code, we're gonna now add a new. I want to show you. Let's just do it like this. Let's add a constant like this. Let's have it in set resolution only. Let's put everything at 0. Make sure this is 32-bit. Let's have this in a null that we will call orient. And let's plug this in our rotations. So because we are, even if we're working in 2D, we're actually in a 3D world. We want to rotate around the z-axis, and I can demonstrate this if I rotate only the r value here. Oh wait, let me put everything also, yeah, in r, g, and b like this. If I rotate only the r value you see that we're not turning around the x-axis, the right axis. We are turning around the x-axis, which is not the right one. If we do it same thing around the y-axis, we're not turning around the right one. So obviously we want to rotate around this z-axis, which will be exactly what we're going to be trying to do. Okay, so that's what we need to do. So let's bring in, so let's make this even a bit smaller because it's still too much in my face. Okay, like this I like it better. Okay, now that we have our setup kind of ready, let's do our orientation. So let me just close this and let me right click on this wire and insert a GLSL top. In this GLSL top, we will need a new vector, which we will call uTarget, and it's going to be a vec2, so vector with 2 components. And for now, let's just have it at 0.5.5. Let's open this code. So this is our old code. Wonderful. And let's bring in a uniform, which is going to be a vec2, which is going to be called uTarget. Okay. I want to grab all those positions from my GLSL UV here, and I want to import it in my new GLSL, which I'm going to recall right away, GLSL orientation. So for this, it's super simple. This was actually commented out right here. So let's rename this color to position. Let's be sure to just use the 2 components. So it's a vec2 in position. So we don't touch this. We'll use it as is, but we'll just use the RNG component. Okay. So this is our position, and then we have another vec2 we need. We're going to use it target, and we're going to use uTarget. So we could just use uTarget right away, but why not have it a bit neater? Okay. Next, let's create another vec2 that we will call direction. So if we remember what we said earlier, let's do target minus direction. Okay, direction, no, not targets, target minus position, which will make a lot more sense this way. Okay, now that we have this, let's convert those in degrees. So let's take float orientation, and let's say a tan from direction Y, direction X. Super simply. Okay. And finally, all right, let's convert all this in degrees. Obviously, we could also just do this and convert the degrees right here straight up, but let's make it a little more readable just because. So this would work also. Okay, we would have to take that out, but this would all be the same. But for clarity's sake, let's make it in 2 steps. Okay, so let's output it in our color buffer here. So let's put orientation as the R value, and everything else can be at 0. Let's keep the alpha at 1 just for fun. Okay, so we kind of okay, so we kind of see something worked here. It's kind of looking funny, so let's go back solely in touch and look what's going on. So nothing is going on right now. Oh yeah, some things are going on actually. So let's take everything out, and we just exported the R in our our null orient. So let's put our R in the Z value, and this is a capital R. Okay, let's look at it now. So now we see that if I move it up here, everything moves, but right now the circle and the actual targeting are not bounded. So let's do just that in a very easy and chop way. So let me grab this, let's put it over there for now, and a bit smaller and a red up there. Okay, so I'm gonna bring in some noise. And I'm gonna put it in time slice like this. In channels, I don't want to have it named channel 1, but I want T bracket XY. This will give me 2 channels with the same noise parameters, but with different seeds. Right now, our noise is centered at 1 and is oscillating, moving around with an amplitude of 1. So his maximum is 1 and his minimum is -1. So let's rearrange this with a math, because on our y-axis, if we remember looking at this, we can see that our particles, our points, are going from 0 to 1, and on our x-axis we're going from 0 to the value of our aspect ratio. So let's implement that. So from here, we know we're going from -1 to 1, so that is good, and we want to go from 0 to 1. So this is perfect for the ty value. So a nice way to keep often your network not too spaghetti is in the scope here. Without adding branches, we're going to do everything in one single stream. So this should only affect the ty channel. Tx is exactly the same that it was in the noise here. Let's add another math, and this is the exact same thing what we're doing, that just starting it here, as long as we're specifying the scope here. So let me do this right away and rename it in the right fashion. Okay, and this time we're going still from -1 to 1. That did not change. But we're going to go from 0 to, you know it, our aspect ratio. And we can put a null here and call it, let's call it chord for coordinates of the target. From here, let's put the viewer active here and just slice it in. Reference it here and on the y-axis, and let's do the same thing for our fake data that we had prepared here. And there we have it. So why is this there? There we go. Okay, so let's put a little color around all those. Yes, like this. And if you've watched a bit of my tutorials, you know that I just love to add this little cartoony look. So you can imagine there's a ton of things we can do from here. Let me just pump up the resolution here. There's a ton of things we can do here. First of all, let's make this, go a bit slower. Wrong way. Superb. Let's make this circle also a bit smaller. This should be fine. And let's make it like red, because it's our target. It has to be clear that we're gunning for it. So there's not much, I think, in this tutorial that is crazy difficult. I think it's a good stepping stone to understand this process, to do a lot of cool particle effects where the particle will orient to some destinations. Let me put on just a little background here so it's a bit more fun to watch. Not like this. Yeah, why not? I can live with that. Or can I? I don't know. That's not the point. Yeah. So I guess that's pretty much it. So I'll try to do pretty soon a part 2, which will deal on how to do this in 3D, which is pretty similar but a tiny bit different. Hopefully you've liked this tutorial. If you did, please comment, leave a like, and tell me what you'd like to see next. And if you do anything fun with it, please share it with me. I'll be happy to share it myself again. So have a good day, and